have ax equals to m x minus t. Okay, x minus t. Here our task is to subject x. Okay, subject x. Try to understand what's happening here. Because this is not like as our previous cases, because in both sides, in left side and right side, both side holding x particles. So we have to bring x together. Okay, we have to bring x particles together. That's our first task. So ax, okay, I am going to expand. Okay, I am going to expand this expression by using m. So m multiplied by x, it would be mx. M multiplied by negative t, it would be negative mt. Okay, negative mt. Furthermore, I have to subject my x now. So I have to bring all the x particles to one side of the equation. So I'll bring this x to this side. Okay, so ax, this positive mx, okay, positive mx, that will become a negative mx to this side. Thereafter, we have some remaining values. In that case, negative mt, okay, mostly you will make some mistakes over here. Okay, forgottenly you will write it as empty. This is not only empty, negative empty. The direction is very important. Then after, in both, we can select x as our common factor. Okay, we can select x as our common factor. So when you select x as the common factor here, in ax when you brought x, there is a remaining. In mx when you brought x, there is a negative m remaining. That's equals to negative mt. Negative mt. Thereafter, to finalize our answer, here we need what we need. That's x. So x remains same. X is multiplied with this total function. So you cannot bring this negative m as a positive m. Okay. This whole function is multiplied with x now. So let's bring that as a division, the total value inside the brackets, that will become a dividend to another side. So that would be equals to a minus m. Negative mt, that's equals to, okay, sorry, x equals to negative mt upon a minus m. Let's see a quick recap. Here in both sides we have x particles. So which x we have to subject? We don't have any idea now. So we have to bring x particles together. That's why I expanded the right side expression by using m. So m into x mx, m into t negative mt. Then I brought this x to this side because we have to keep our all the x particles to one side of the equation. That's why I brought this one to this side. So that will become ax remains same. The positive mx, that became negative mx. There is a negative mt in right side of the equation. Then after, in these two, okay, in these two values, both holding x particles, no, we have to subject x. So I brought, okay, I just brought x as my common factor. So what's the remainder in the bracket? We have a minus m, which is equals to negative mt. Then finally, x would be equals to negative mt. The multiplicand a minus m, that became a dividend a minus m. Yeah, same as previous one, but t is in our denominator. So what do we need to do? You should bring this t as a multiplicand to this side. So mt equals to kt minus x. kt minus x. So then after, let's bring t particles together. So for that, mt remains same. I'll bring the positive kt as a negative kt to this side. Then after, in right side, we have only negative x. In these two, I can make t as a common factor. So what's the remaining? m minus k. m minus k, which is equals to negative x. Finally, our t would be equals to t multiplied with this m minus k. No? So negative x, the multiplication, okay, the multiplied value of m minus k, that will become a divided m minus k. That's the way you should find your answer in this case. 1 upon v, okay. All the values are in its reciprocal form. So first of all, let's substitute the values. 1 upon 20 plus u 1 upon 5, which is equals to 1 upon f. Okay, 1 upon f. We cannot add these two. So, because here the denominator is 20, so its denominator is not 20, no. So, you should multiply both numerator and denominator by number 4. That will give you 1 upon 20 plus 4 upon 20. We are writing equivalent fraction to get our denominator as 20 equals to 1 upon f. Here you can add this as 1 plus 4, which is 5, 20. Denominator would be 20. That's equals to 1 upon f. Okay, that's equals to 1 upon f. Then after, what we can write is, you should multiply this. Okay, earlier also I explained you that if the particle which we need to find that is in denominator, you should convert it as a numerator. In numerator form only you should represent your answer. So I am going to multiply 5 into f. 5 multiplied by f, which is equals to 1 multiplied by 20. 1 multiplied by 20, that's only 20. Then f is equals to 20. 5 and f are in multiplication, no. So to oppose that, we are going to divide 20 by 5. That will give you f as 4. F is not 1 upon 4. Okay. When you simplify this over here also, 1 upon 4. But that is not the exact answer for f, because f in its denominator form, you should make it as a numerator. For that, I am going to cross multiply. We have two fractions in between. We have an equation mark. We can express it as a cross multiplication manner. So 5 times f would be equals to 1 time 20. After simplification, you can receive f as 4 over here.